Okay, let's look at some post optimality analysis for this marketing problem. So we can set up slack surplus. Okay. Now remember, for less than or equal to constraints, okay, you have to go the right hand side minus the left hand side, because the right hand side will be larger than the left hand side or equal. Whereas in greater than or equal to, you have to go the other way around, because slack or surplus can never be negative. So the easiest way of doing this is to simply do an absolute value of the difference. Okay, the limit minus the actual. Okay, so this way it doesn't matter which way you go, you'll get the correct answer. Slack is for less than or equal to constraint, surplus is for greater than or equal to constraint. So you have a limit of 12 spots for the TV ad, and we are running only 2. Okay, so here, therefore, this constraint is not binding. So binding or not binding, so this is non-binding. Okay, the next one is binding because the slack is 0. We are running uh, the number of ads we are running is at the bound. Okay, and same here. Let's go ahead and copy the formula here, and these two constraints are also not binding. So because we have a limit of 8,000, we are running only 7965. Limit of 1800, we are spending only 1740. Okay, if we want sensitivity report, then we have to run solver again, but sensitivity report for when you have integer constraints, it won't work. So if you want sensitivity report, then you have to go back. Okay, let's get rid of that. Set it to the original model. Now you need to remove the integer constraint. Delete that. Okay. Now run solver. You get your sensitivity report. Okay, so there it is. Then we can go back into solver, add the integer requirement. Okay, so that would be integer. All right, then you solve again. Now see, when you solve with int constraint, you will get only answer report. You will not get sensitivity report. So you have to be careful when you interpret the sensitivity report. We are actually interpreting it for the non-integer linear programming case. So here are the allowable increase and decrease, okay, and here are the shadow prices. And remember here, when you're running a linear programming problem, then the shadow prices of 0, they represent non-binding constraints. So these 4 constraints are non-binding constraints, and the shadow price here for these 3 constraints. So this one is the newspaper ads. Okay, we have a limit of 5. Now, what is the shadow price? The shadow price is about the objective functions. The objective function is how the audience reached. Well, so that shouldn't be dollar. That should be just regular number. Okay, the audience reached is 66,900. So the shadow price is in the same unit. The audience reached. So if you relax the right hand side of number of newspaper ads that we can run from 5, if you increase it to 6, and you are allowed to increase it up to 1.7. So if you allow it to go to 6, then you will be able to increase the audience reached by that amount. And on the flip side is, if you decrease the limit from 5 to 4, okay, again, you can go all the way down to 0 for the shadow price would still be valid. So this will be the number of audience reached that you will lose. Okay. And similarly here, this is the total budget. Okay. And the total budget can go up by increased. Allowable increase is $8,025. Allowable decrease is $1,575. For each dollar that you increase, the audience that you can reach will go up by 6.25. And similarly for radio ads cost, so if your radio ads limit of $1,800 is relaxed, and again, these are the allowable increase and decrease for the shadow price to be valid. So for each dollar that you increase the limit by, you will be able to reach that many additional audience.